Alright, so this is Mrs. McIntyre. This is the start of geometry. Exciting stuff. And today in the first lesson, I'm just going to talk about points, lines, and planes, and like when they intersect. I'm not going to go over all this vocab because that would be super boring, but you on your own time need to look up the definitions of these words if you don't already know them. I'm sure most of them, if not all of them, will look familiar to you. You've used them before in middle school or even elementary school geometry, but you just need to make sure that you know how to represent them. For example, if I was going to name a line and 2 points on the line were AB, then I could name that line AB, shocker, but you do need that notation above it, right? So that line could also be BA, but if you don't have that line there, then I don't know if it's a ray, I don't know if it's a line, I don't know if it's a segment. So not only do you need to know, you're like, oh, I know what a line is, yeah, but can you name it, okay? And so that'll be true for point, plane, segment, ray. You would need to know the symbol for congruent. Hopefully you can, it's kind of obvious which ones you would need to know how to, what the notation is. Collinear doesn't have a notation. Alright, so on your own time, look up those words, and then you have the space if you want to write down definitions or just something to remind you what it is or what it means. That would be fine. Okay, next page. Okay, so the intersection here, you just need to know that when two lines intersect, what they have in common, or their intersection point, is just a point, right? That point right there is what they would have in common. So the intersection of two lines is a point. Okay? Now when two planes intersect, of course we're talking about geometric planes and not fly in the sky planes. Sorry, that's just a little joke that I do. So when these two planes intersect, they just have a line in common. Okay, so I just stole this from Google because at no point could I draw two geometric planes intersecting and make it look realistic at all. But if you can imagine those two blue rectangles as sheets of paper or something, and just intersecting, sliding through each other, you're gonna have a line that's in common. Okay, so you just need to know that. So intersection of two planes is a line. We'll fill that in. Okay, now just a couple questions here referring to this diagram. I'll just do one or two so that you get the gist and you can finish it. It's pretty basic, but a point that is coplanar with the given point. So for A, B, and C, if I look at A, B, and C, obviously that fourth point would be D, right? So coplanar in the same plane. So what you're envisioning here, sorry, let me scurch on up. There we go. What you're envisioning is if you had a sheet of metal, just flat, or even just a piece of paper, could you lay that paper on top of the plane so that it hits all the points without bending it? That's the important thing, without bending it, okay? So D, C, and F, boom, boom, boom. So obviously, B wouldn't work because you'd have to bend the paper. E wouldn't work. The only other point that's right in the same plane as those would be G. Okay, so if you just want to fill in those other three questions, that would be great. All right, now the last page for this lesson, I'm not going to go over all of these, but I'm just going to talk about a few to get you started so that you can finish on your own. Okay? So I kind of already addressed number one, on the first page. Give 5 other names for AB. So if you go to the line AB, first of all, you could also name it BA. You could just flip those letters. But G is also on that same line, so I can name that line with G. I can name it GB, GA, all those combinations. So you should have 5 other ones listed here. 4 sets of 3 points that are collinear, so just 3 points that are on the same line. You should be able to figure that out. 3 points that are coplanar with plane K and plane L. Now, they named these planes, right? So that K is referring to this plane here, this rectangle, and plane L is referring to this one. So if you want 3 points that are in the same plane as both of those planes, you should probably look at the line that is formed where they intersect. Okay, that's all I'm going to say. I don't want to give it away. Let's see. You can figure that one out. Figure that one out. Number 6, name all arrays with endpoint G. So if this is G here, array is, well, you should know what array is, right? It ends at like one point and it goes on forever in the opposite direction. So like G, C, that would be array with endpoint G. GB would be array with endpoint G. So I want you to list them all and I want you to watch your notation. So GC is array. Now it extends forever in the direction of C. So the arrow needs to be with the C. I could have flipped that around. I could have put the C first and then the G, but then you got to flip the arrow. Okay, I know, like, very minor details here, but they matter a lot. Okay, they matter a lot. Is that correct grammar? That's fine. So all rays, name all rays there with endpoint G. 4 pairs of opposite rays. Okay, so for an example of that, GC and GD, they would be opposite rays because they start at the same point but then go in opposite directions. Okay, you can figure that out. And I think you should be good to go. So finish all 16 questions, and then you can check the answer key or we will go over them in class. Thanks for watching.